Morning, everyone. Myself, Monica Nancy Priya, Assistant Professor in the Department of Electrical and Electronics Engineering. In this semester, I'm handling W3017 Embedded C Programming in the Regulation 2021. Um, Today, we are going to discuss about object-oriented programming, commonly called OOP, using C++. So OOP is a programming paradigm that focuses on objects rather than function. In real life, everything around us is an object, a car, a student, a mobile phone. Similarly, in OOPs, we model real-world entities as an objects. In C++, strongly supports OOP concepts, which help us organize complex problems, programs, improve code reusability, increase security, make programs easier to maintain. On the next slide, procedure-oriented versus object-oriented programming. In POP, shortly we have mentioned is POP. In POP, the focus is on functions. The data is shared globally, so it is a less secure. But in OOPS, it mainly focuses on objects. The data and functions are combined together. The data is protected using encapsulation. For small programs, the POP works fine, but for large real-time application like banking systems or management systems, OOP is more suitable. In the next slide, it's a basic concepts of OOP. The OOP is built on six major principles: class, object, encapsulation, abstraction, inheritance, polymorphism. First, what is class? A class is a blueprint or template used to create objects. It defines data members and member functions. What is data member means? It's a variable, and the member function is it's a method. Next one is the object. The object is an instance of class. It represents a real world entity and occupies memory. The next one is encapsulation. Encapsulation is the process of wrapping data and functions together into single unit, that is class, and restricting direct access to data using access specifiers. The next one is abstraction. What is abstraction? It's the process of hiding implementation details and showing only essential features to the user. The next one is the inheritance. The inheritance is a mechanism by which one class acquires the properties and behavior of another class. This is the inheritance. The next one is the polymorphism. The polymorphism means it form a many forms. The ability of a function or objects to behave differently in different situations. And now let us see about the each topic. First, what is class? A class is a blueprint or template. For example, if we want to create many students, we define a class called student. So a class contains data members, that is the variables. And the member function is function, that is methods. Okay. So syntax, what is the syntax? Class name, int. We are giving int roll number and void display. Here student is the only a blueprint. It does not occupy memory until we create an object. So if we create an object, then it occupies a memory. Okay. Next, what is object? Now, object is the instance of a class. If a class is a blueprint, object is the real building. So, for example, student S1. Then here, what is the example? Class name, object 1. Here, object 1 is the object. Here the memory is allocated because we are using here object in the class name. But before we don't have a memory allocation because there is no object is needed. But here the object is needed, so we are placing the object in the name of class name. So the memory is allocated. We can now access the class members. Object help us work with the real data. Okay. Next one is encapsulation. Encapsulation means it's a wrapping of data and function into a single unit. This is achieved using classes only. So we use private, public, and protected. In private data cannot be accessed directly from outside. This improves security. For example, think of a bank account. You cannot directly change your balance. You must use deposit or withdraw option. So this is the encapsulation. So it improves security. Next one is the abstraction. Abstraction means showing only essential details and hiding internal implementation. For example, we are taking as a ATM machine. When you withdraw money, you can insert the card, enter the PIN, and get the money. This is the process. You do not know how the machine process internally. So this is the meaning of abstraction. You are inserting the card, you are putting the PIN number, and you get the money. But the process inside the ATM machine is you don't know means. So that is the abstraction. In C++ also, abstraction is achieved using classes, abstract classes, and access specifiers. So it reduces the complexity. Next one is the inheritance. Now, what is inheritance? It occurs, inheritance is one class acquiring a properties of another class. So, for example, we have a class person. Student and teacher can inherit from person. This avoids rewriting the same code. We have the different types of inheritances in this. We have a single, multiple, multi-level, hierarchical, hybrid. This inheritance improves the code reusability and maintainability. Next one is the polymorphism. It's a polymorphism means it's many forms. One function behaves differently in different situation. It can have two types. One is compile type polymorphism and the second one is the runtime polymorphism. Compile time is the function overloading and the operator overloading. In the runtime polymorphism, it have a function overloading. For example, a function called add. We have to add two numbers. So add in the bracket of integer, integer. So we are having a two values as an integer. Or we have to add float, float. We are having a two numbers as a float. Same function name, but different behavior. Okay. Next one is the constructors and destructors. What is mean by constructor? The construction always performs the special functions and have the same name as the class. And it's also used to initialize the object. For example, we are having a student and the roll number is equals to 0. This is the constructor. What is destructor? It cleans up the memory. If you want to initialize, you have to use the constructor. If you want to clean, you have to use the destructor. It's always start with that prefaced with this symbol. It's approximately this symbol. So we have to start with the examples. It's the symbol with student of bracket. So constructor runs when the object is created and the destructor runs when the object is destroyed. Then the advantages of OOP. Why do we use OOPs? It has a code reusability, data security, easy maintenance, better problem solving, and real world modeling. For the larger applications like banking system. Banking system means we have using the data security. Okay. Next, hospital management. In hospital management, we have used better problem solving and code reusability. In game development, we are using the real world modeling. So we are all built using the OOP concepts only. So in this conclusion, what we are studied, what we are seen about the last slides, the OOP help us to write structured and organized program. C++ strongly supports classes, objects, inheritance, and polymorphism. If you understand these six types of six types, you have to understand the how we are writing the software program, how it is used in the software, how it is used in the games, how it is used in the system programming, how it is used in the real world applications, hospital management. All we are study about the past slides. So these are the references. Thank you for watching. We'll see you on the next class.